So, can you hear me? Okay. So thanks for having me. Welcome to Bashing on Bash Talk 2, Bashing on Bash with Clojure. So this talk is about Babashka, a tool that I made, and also about the small Clojure interpreter which came out of Babashka. My name is Michiel Borkent, and I'm also known as BorkDude on the internet. So if you Google BorkDude, you'll likely to find some information about me. So in the last year, I've been developing some tools using GraalVM and Clojure. And I've been only using one part of GraalVM, which is the native image compilation ability. And what it does, or what you can do with it, is compile executables that have very fast startup, like less than 10 milliseconds startup. And that's not what we're used to with the JVM. So I think that opens up a whole new world of tools that we can make with Clojure, and I'm very excited about this. One tool that I've created with this is CLJS. You might have heard about it. It's a linter for Clojure. It works with GraalVM, and it's only 5 megabytes zipped, so it's very compact, and it works, and it's embraced by the community. So GraalVM and Clojure, I think this is one nice example of what you can do with it. Another tool that I've made is called Jet, and it's a simple tool to convert Eden to transit to JSON between those formats. It's a bit similar to JQ. It also has a query language. I use it to, in my day job, I work with large blobs of transit that we send between the server and the client. And it's not so nice to read those blobs, so what I do is just paste them in a file and then convert it to Eden with Jet, and maybe do some querying to inspect what's inside of it. Last year we had Jan Stemkjen. I tried, sorry. And with a great talk about GraalVM, and he also highlighted what you can do with GraalVM and Clojure. But he also mentioned one constraint that does not work with GraalVM, and that is eval. We cannot do Clojure core eval in at runtime in GraalVM programs, because GraalVM does not support dynamic class loading. So now we have a problem if we want to write something like a scripting tool with GraalVM. So when I was writing Jet, I was writing a query language, and this was basically a case statement on like 20 functions like map, filter, reduce, and then so if the user provides a list that has in the first position something like map, then I execute map. And basically what I did here was write a small interpreter. So then I thought, well, this works with GraalVM, and I don't need Clojure core eval for this. What if I extend this to normal Clojure programs to a significant subset of Clojure? That would be quite cool. Then we would have Clojure programs with instant startup. So that is what I've been doing with Babashka and the small Clojure interpreter. So on the question marks there, that's what I fantasized about when I made this query language on the way home from Heart of Clojure in the train. And so that's what I've been doing. This tool is called Babashka. It is a GraalVM compiled tool that has, like, if you execute this expression plus 1, 2, 3, it does it in 13 milliseconds. And you don't need a JVM. You only download this tool on your machine, and that's it. So you can execute arbitrary Clojure expressions. And I use it to replace the gray areas of Bash. And I don't need to repeat what Jakub said in the previous talk about Bash. Like if you write more than 5 lines, I wish I had Clojure. That's basically the summary. And you can install this tool using Brew, or just download it, or using a package manager in Linux or Windows. It also works on Windows. So that's Babashka basically. So this was the talk. Oh, we do have some time, so let me tell some details. Okay. So how does Babashka compare to several other scripting solutions? So of course we can use Clojure itself to do scripting. That is, I find, the most flexible solution because you can add libraries at runtime and you can use real threads and things like this. But it has a startup penalty of like 1.5 seconds, which is not what you're used to from Bash. That is a problem basically that Babashka is trying to solve with some trade-offs. We also have Plank. Plank is based on Clojure script, self-hosted Clojure script. And it has already better startup, like about 1 second, but still not that great compared to Bash. Another solution is Joker, which is a Clojure interpreter in Go. That has already quite good startup, 50 milliseconds. That comes close to what you're used to from Bash. And they are working on improving this even more. It's not fully released yet. But it's implemented in Go. And if you want to maintain this tool, you have to write Go. And I don't write Go. So also it does not do interop with Java classes. So I thought maybe there is room for one more. And that is Babashka. It has 13 millisecond startup. It does interop with a pre-selected collection of Java classes, and it also can use real threads on, like you're used to on the JVM, unlike some other solutions. So these are the goals that I came up with when developing Babashka, because when I started the interpreter in Jet and slowly moved to full Clojure, I didn't know all the goals, but compared to other solutions, I think these are where the goals where Babashka shines. So it can be a Clojure scripting alternative for JVM, specifically JVM Clojure. It should be easily installable. Just grab the binary and go. And it should be familiar. So it shouldn't have like magic DSLs or magic constructs. You should just be able to run a script with Babashka and run it unchanged with the JVM Clojure. And it should be portable. You should be able to write the same scripts on Linux as you write them for Windows, for example, which is not the case in Bash, or maybe if you download some Sigwin or stuff like that, maybe you can make it work, but with Babashka it should be easier. There should be interop with commonly used classes like system, file, Java time, and Java Neo. We have multi-threading, and we have some batteries included like tool CLI to parse command line arguments, Cheshire for dealing with JSON, stuff like this. So it should be a batteries included scripting solution. So this is an example of what it can look like to use Babashka on the command line. Well, here we parse the output from ls, and the -i flag turns the input into a sequence of strings, and then we filter this sequence of strings with an anonymous function, and we use some Java interop to filter only the directories. So then it prints, by default, BB, that is Babashka for short, prints out Eden, but you can also make it print like lines of text, so you can use it with the next bash command if you want. So this is an example of a one-liner. Of course, you don't want to repeat yourself, so you can also store some predefined functions in a environment variable. So here we put the isDirectory function in the environment variable, Babashka preloads, and if you put this in your bash RC, you can just use it from anywhere now. So now we can say filter is there instead of this interop blob function. So we have the same result. Full scripts, I think this is the most interesting, because one-liners you can maybe still do with Bash, but if it gets more complicated than 5 lines, you should be using Clojure. So here, this is an example of where we use the Java time API to calculate the current time in Los Angeles, where some of my colleagues are, or California. So I'm not going to explain the script. I just want to show that real Java interop is supported with this tool. And if you execute this, well, you see the current time in California within like 20 milliseconds instead of 1.5 seconds. So, and it also works on Windows. We live in a time and age where this is hip and cool again. If your software works on Windows, so that's why I'm showing it off right here in the command.exe, like in my childhood. Okay. So yeah, we included a set of predefined libraries that are just baked in this binary that you can download. Clojure core, Eden, Java shell, Java IO, set, string, test, and Clojure walk. So the cool thing, we just have Clojure test available, so you can write tests that execute within milliseconds. And now it becomes easy to write tests for scripts. And whoever wrote a unit test for a bash script? I did it once, but it was not as easy as it would be with Babashka now. So I think that's another plus. So we have Clojure tool CLI, we have Clojure core async. All the thread operation works, so with the double exclamation marks. Only the go macro doesn't work. That's maybe work in progress, or maybe it won't ever work. I'm not sure yet. That's complicated. So we have Clojure data CSV, we have Cheshire.core for dealing with JSON, and we have some utility functions like waiting for a port to open or a file to exist. And we are evaluating Clojure XML. Technically that's possible, but that just has to be implemented. We will add something around YAML, although I hate YAML, so maybe I will resist as long as possible. No, it will be added. And maybe an HTTP client, although you can just use Clojure Java shell with curl, and that works as well. So maybe that's not even needed. But Babashka also supports external libraries. So if you have like scripts that you want to put on GitHub and run in your CI, you can just clone your scripts, or even write libraries that you add on a class path that Babashka supports. And one such example is a library called Spartan.spec. It's a subset of Clojure spec, that's why it's called Spartan. And so you can add it to the class path for BB and then execute a spec expression within well, it's about 80 milliseconds to load this whole library. Then you can use Clojure spec. So we have other libraries. I can't enumerate them all because that takes too much time right now. But the latest hotness in regular expression land is called Regal. It's a Lambda Island library that is also compatible with Babashka. I didn't have to change anything to Babashka to make this work, because it supports a sufficient large subset of Clojure that it just worked. Okay, so how do you add things to the class path? We just use existing tools. We do not reinvent. We do not write our own class path and dependency resolvers. That's too much work. We just use the Clojure tool, or you can use Leiningen or whatever creates a class path, boot. It's fine, and you just put it in the environment variable Babashka class path, or you pass it as a command line argument to Babashka. That also works. And now, if we have the second, the program in the middle, spec.clj, we execute some spec expression, and well, that works at the bottom. So this is how you can use libraries. And Clojure has caching for class paths. So if you execute Clojure command for the second time, it's very fast. So this is how you can still get fast startup times while still using the normal Clojure command. Okay, so this is Babashka. But while creating this, I made some parts inside Babashka that I thought could be useful maybe for others also to use. And if you are implementing an interpreter, the first thing you have to do is parse code. So this was the first thing that I wrote, was called Edamame. I will explain it a little bit more in detail in the next slide. And SCI is the other library that came out of this. It's short for Small Clojure Interpreter. So first, Edamame. You pronounce it like Edamame. So if you get only one thing out of this talk, you now know how to pronounce Edamame. It is, it is food. It is baby soybeans, basically. I never eat it. Well, maybe I had it once or twice, but I just thought it was a cool name for a library that could parse Eden and more stuff. So, so it can parse Eden, and why did I start with, it's based on tools.reader.eden and not on a normal tools.reader, and the reason is that the normal tools reader is not compatible with GraalVM. So it has something like resolve or eval inside of it, and that breaks GraalVM compilation. So I had to rewrite this from scratch, starting with Eden. That is basically what Edamame is, plus one by one adding code features from Clojure. So at the bottom we see an example where I parse an anonymous function, and this anonymous function is not part of Eden. So you have to turn that on explicitly by saying fn true. So then it will become Eden plus anonymous functions. And now it can parse anonymous functions, and what you get back is an S expression, fn star, and then the argument and then the body. But this is still not a function, it's only an S expression, so it is not interpreted yet. So that is the job of the small Clojure interpreter. But what Edamame also does is add metadata to these S expressions. So you can see from which line and column in the text are these expressions coming from. And this is used for producing error messages. So if you have like a 1,000-line Babashka script and you made a typo somewhere, it's not sufficient to say you made a typo somewhere. So you want to say you made a typo on line 1,000, column 20, for example. So this is what Edamame also adds. And you can parse Clojure core with this. It supports all the things in Clojure, but you can tune it at your option to extend Eden with features, reader conditionals, things like that. So the small Clojure interpreter, it uses Edamame to parse code. It works on JVM, but also in GraalVM, obviously, but also in JavaScript. So while doing this interpreter, I thought, well, this is now .clj, but I can also make it .cljc, and without much effort, I can make it work in JavaScript, which is cool because this is written in Clojure, and a large subset of Clojure is compatible with Clojure script, so there was not that much that I had to do. Well, in the beginning, later on, it was more difficult. But then I already decided to support JavaScript. It has sandboxing, so you can say I want to allow only these functions and not all these other functions from Clojure core. And it also has a mechanism to prevent infinite evaluation of sequences. It works even in ClojureScript advanced compiled applications. So you can include this interpreter and then advanced compile your application, and it still works. And I think this is a benefit over self-hosted ClojureScript, which cannot do this. And if you're using self-hosted ClojureScript, this is about 8 megabytes of JavaScript. And small Clojure interpreter is now 600 kilobytes, of which 200 kilobytes is docstrings. So you so if you need like a smaller, so it's about 100 kilobytes gzipped, I would say. If you need a smaller version of SCI for your application, you can easily make a fork and exclude all the docstrings and stuff like that, and then use this in your application if you want a smaller binary, if that's a concern. And maybe we will think about how to make this inside SCI to make smaller compilation targets possible as well. It has a Java API, so you can use it from Java and also from JavaScript directly. So you can directly say npm install borkdude SCI and then eval string away. So on the bottom we see an example where we evaluate this anonymous function that we parsed with Edamame on the previous slide. And what we get back is a regular function that we can then execute in our regular Clojure environment. So one application of this, where it's not used in Babashka but somewhere else, it was already mentioned in the talk this morning by Tommy. Mali uses this to create serializable schemas that include function predicates. So we see this is a schema that says, well, x and y should be an integer in this map, but we also want to have an additional constraint. And if you put the quote in front of this function, then you can send it between several environments, like front end and back end, and then it will invoke SCI to evaluate this function for you. And you can store this in a normal file, I think, normal Eden file. So another application that I found myself for SCI in Jet, so it's full circle, I guess, is making function command line arguments. So in Jet, I can parse JSON, but often we want to keywordize the keys in a special way. So for example, here I'm parsing JSON, but I want to keywordize all the keys and capitalize them first for some reason. It's ridiculous, but maybe someone wants to do this. So the expression that follows keywordize is then evaluated by the small Clojure interpreter, and because that is compatible with GraalVM, this entire tool can now still work in GraalVM, and you can still have these dynamic evaluations. And the same is true for the Eden reader options that Jet supports. So you can say, I have a reader tag foo, and I want to use this function to handle this reader tag. So what does it look like if you use SCI from JavaScript? You can just say npm install bork.sci and then require it and then eval string. So here we eval string a Clojure map, or sorry, a soch, and then with a Clojure map, and we add a key and a value. So what we get back is a Clojure value. So X is now a new Clojure map, but in JavaScript you cannot do much with Clojure data structures. So we also included one function in the API that converts a Clojure value to JavaScript objects. So what we get back then is a JavaScript object with a key and a key A and B. So this is how you could use it in JavaScript. Why would you use this in JavaScript? Well, I'll tell you later. Okay. So how do you add libraries to SCI? Because Babashka has Cheshire, for example. But SCI doesn't include all these libraries by itself. It's just a bare bones Clojure interpreter. So how do you add libraries? Well, you can just say in the options that you pass to SCI, well, these are the namespaces in my environment, and I want to define one namespace called Cheshire core, and then I want to include the function generate string, and there we pass the function object that is coming from the Cheshire library. So we just mirror the library inside the options of SCI, and then it works. So on the bottom you can see in the eval string we require Cheshire and then call this generate string function, and that works. So this is how you can include libraries, provided that these libraries work with GraalVM. So SCI cannot magically make all the libraries work with GraalVM. So these libraries that you will include still have to be compatible. If they are using eval or something, that doesn't work. So using this small, this is the obligatory animation that I had to put in because I had too much time left. So there are several projects now using the small Clojure interpreter. One of those tools is Bootleg. Bootleg is a static HTML generator tool. So it includes templating libraries like Selmer. So we have Clojure, which is currently experimenting with making the tool work on GraalVM. which Jakub already explained. We have, of course, we have Babashka. We have now Spire. Spire is a provisioning tool like Ansible, but then using Clojure. I'm very excited about that one. I'm curious where that goes. And we have several other tools. So one application of using SCI in JavaScript is making Slack bot, which is a Clojure REPL. And this is what Roman did. He sent me an example of this. And so they made a Google Cloud function where they required SCI and then hooked it up to the Clojure, the Google Cloud function, and then hooked that up to Slack. I think that's a nice way of using this interpreter. Okay, this is not just a tool, but to re-emphasize that there are several companies already looking at Babashka or SCI, and maybe not fully having it in production, but at least evaluating it in their developers at these communities are looking at it. I work at Dr. Evidence, or I'm contracted with Dr. Evidence, which is a very cool company, and all my colleagues are also here. Oh, maybe they're looking surprised now that we are using Babashka, but I do. Okay. Let's see. So I think there can only be one logical conclusion to the previous talk and this talk, which is Clojure is the best language for scripting. Don't you all agree? Yeah. Yay. Okay. Thank you very much.
Thank you very much. I can imagine that there is a question or the other in the room. Oh, yeah.
Hello, thank you for the talk. Can you expand on the sandboxing? Is that by whitelisting what you need, or can I say that I just want to be able to evaluate pure functions?
Yeah, you have to, by default, SCI only allows, well, pure-ish functions. So functions that do not mutate the outside world. For example, swap is not a pure function, but inside the environment, it doesn't matter if you use swap. So SCI only provides access by to these functions by default. It doesn't map like Clojure Java I/O or something inside of. You have to do that yourself. So that is how sandboxing is more or less safe by default. Yeah.
What's the support for auto-completion? Like, for example, if you want to autocomplete on files, I imagine we'll use this as a shell again, like last thing.
So there is one editor called Atom. No, sorry, it's not an editor. There is a Clojure plugin for Atom, an editor, which is called Chlorine. And Chlorine made autocompletion for Babashka, and it uses the ns-map function. So ns-map returns a map of all the symbols that are currently accessible in the namespace, including Java classes. And so it uses this to implement autocompletion in the Babashka REPL. Babashka also comes with a socket REPL. So I could imagine that different environments have different needs. This is one example of how one environment implemented this. And I'm not sure about bash completion myself. I haven't looked into that yet.
Anything else from the audience? Oh yeah, over there.
Hi. Are you planning to add CLJ condo to Babashka, like checking?
Sorry?
Are you planning to add the checking of CLJ condo to Babashka?
No, because it's already a tool that you can use. I mean, it doesn't have to be inside Babashka. That doesn't. So I could implement all these checks, like, well, this type isn't correct or something, but that's already happening over there, so I don't think there's a need to do that. I think you maybe had a question. very quick one.
Hi there, do you have any support for SQLite libraries or anything to do with networking like DNS lookups and stuff?
So the first question was SQLite.
Yes.
I have one example. There is an examples directory in the repository where I just shell out to the SQLite CLI tool, which is perfectly fine because it's all fast starting CLIs. And for DNS stuff, I don't have anything specific, but maybe there is some Java class that supports something around this. And if you need it and it's not in there, you can contact me and we can see if it's possible to add it. That's it, I guess.
There's one very important thing, Thank you for giving me the possibility to fix this year's conference. Jan, can you please come on stage? Would you help us pronounce your name?
Stępień. Thank you so much.
Now this is You may wonder why this is important, but this is the only guy who has been on stage on every Clojure conference, on every clojureD so far. So, thank you, Jan. This concludes this year's Bash D. We continue with the clojureD after the coffee break at 4 o'clock over here. Thank you.